World War II produced a whole class of airplane built for one job: killing tanks. The most famous of them was Sergei Ilyushin's Il-2. Ilyushin's central idea was that armor should not be bolted onto an airplane as an afterthought. It should be the airplane. The nose of the Il-2 was a steel shell enclosing the engine, the cockpit, and the fuel tanks, armor between 4 and 12 millimeters thick, and that shell carried structural loads the way an ordinary fuselage skin would. Nothing else built in that war worked quite like it. Rifle caliber rounds bounced off, and even 20-millimeter hits often failed to bring the aircraft down, so pilots kept coming home in airplanes shot full of holes. The Soviets built more than 36,000 of them, which makes the Il-2 the most produced military aircraft in history. The German Henschel 129 was a different story. Luftwaffe pilots never warmed to it. Its trouble started with the engines. Germany had nothing to spare in that power class, so production aircraft were fitted with captured French Gnome 14M radials, which left the Henschel 129 underpowered before anyone hung a single weapon on it, and which choked on the dust of the Eastern Front and the sand of Tunisia. The fuselage had a triangular cross-section, and the cockpit inside it was so narrow that some pilots simply could not fit. There was no room on the panel for the gun sight, so it was bolted to the outside of the nose. Some of the engine instruments had to be mounted on the inner faces of the nacelles, where the pilot could squint at them through the side glass. 865 were built. For airplanes like these, the gun was the whole point. Halfway through the war, the Il-2 got a 37mm gun, the NS-37, 2 of them, one in a pod under each wing with 50 rounds apiece. The catch was recoil. A 37mm gun firing from a light airframe flexed the wings and knocked the airplane off its aim point, so that in a burst only the first shot was truly aimed. Pilots were trained to fire in short pairs and taught to live with the dispersion. About 3,500 were built before the variant was dropped. In early 1945, flight tests began on an even heavier 45mm NS-45. The Germans went bigger still. They hung a Bordkanone 7.5 under the Henschel 129B3, a 75mm gun on a single-seat attack plane. That weapon was a converted Pak-40, the standard German-towed anti-tank gun, fitted with a rotary magazine of about a dozen rounds and slung under a fuselage that had never been designed to carry anything like it. To keep the weight down, they pulled the airplane's own MG 150-120s out. About 25 were completed. They went into action in the fall of 1944, and the armor-piercing round they fired would punch through about 130 millimeters of armor at 500 yards, which meant there was nothing in the Red Army's inventory they could not open up. The crews had a name for it: Panzerknacker, tank cracker. Then they sat on their airfields, because by then there was no fuel left to fly them. Anything bigger than 37 millimeters could kill just about any tank on the battlefield. That is what made these airplanes worth having over the front line, right on top of the infantry they were supporting. The Il-2's record on the Eastern Front got everyone's attention, the Americans included. Every Air Force with a front line to support started working out what it would take to build one of its own. The U.S. Army Air Forces wanted its own heavy close support aircraft to replace the aging Douglas A-20 Havoc. The A-20 was a good airplane, and nearly 7,500 were built, but it was fundamentally a fast light bomber carrying machine guns and small bombs. It had never been designed to kill tanks, and by 1944 its production line was shutting down. In 1943, the Army ordered a twin-engine attack airplane from Beechcraft. 2 airframes and no more, assigned the serials 43-14406 and 43-14407. Inside the company, the aircraft was simply the Model 28. The Army designated it XA-38. Everyone else called it the Grizzly. But the program was canceled after only 2 prototypes were built. It all began in early 1942 when the U.S. Army Air Forces issued a requirement for a heavily armored attack airplane with overwhelming firepower. It had to be able to go in against well-defended targets and destroy them. The Army had already tried this once. In 1941, it produced the Brewster XA-32, a single-engine design. The requirement behind it went out on September 6, 1941, and it came directly out of American reports on what German Junkers 87 dive bombers had been doing to armies in the field. On paper, the Brewster design looked reasonable. In metal, it came out close to 20,000 pounds, roughly the weight of a twin-engine A-20, hung on one 2,100 horsepower Pratt and Whitney R-2800. It was covered in bulges and fittings that nobody had bothered to clean up, and when it finally flew on May 22, 1943, it could not manage 200 miles an hour in cruise even with its armament left out, and its combat radius worked out to about 500 miles. It was not meaningfully better than what the Army already had in service, so it never went into production. A second airframe with lighter armament changed nothing. The Army killed the program in 1944, and Congress went on to investigate Brewster's management and found a great deal it did not like. Because of this, the Army Air Forces rethought what it wanted and wrote a new requirement. It now wanted a twin-engine attack airplane, an A for attack type with a crew of 2. Of the designs submitted, the Army picked Beechcraft's, designated the XA-38. Its main competitor was the Hughes XA-37, based on the D-2 and D-5 long-range reconnaissance planes. But that one never left the drawing board. The airframe underneath it did get built, and its story is worth a moment. Howard Hughes made the D-2 out of Duramold, a plastic bonded plywood pressed under heat into large, almost seamless components, and had it assembled in secrecy at Harper Dry Lake, out in the desert near Barstow, California. It flew there for the first time on June 20, 1943, and impressed almost nobody who was allowed near it. The attack designation had been suggested as far back as July of 1942 and was never formally applied to anything at all. In November of 1944, a fire nobody ever explained took the hangar and the airplane inside it, and that was that. There had been another contender before that, too. Curtiss Wright proposed the XP-71, a bomber-destroyer built around a 75mm cannon in the nose with a pair of 37mm guns beside it, an aircraft physically larger and more expensive than a B-25. The company got a contract in November of 1941. The Army lost confidence in it long before any metal was cut, and it was formally canceled in October of 1943 without a single airframe being completed. Beech's engineers tried to meet every specification from the Army Air Forces as closely as possible. It is worth pausing on who those engineers were because Beech was not one of the great prime contractors. Walter and Olivan Beech had started the company in Wichita, Kansas in 1932 with fewer than 10 people on the payroll. By 1937, that was up to 220. By April of 41, a little over 2,300 workers. At the wartime peak in February of 45, 14,110 people. And what they built was trainers and transports. There was the AT-10 Wichita, a twin-engine advanced trainer built mostly of plywood so it would not compete for aluminum. Beech turned out more than 1,700 of them, and subcontracted 600 more to Globe Aircraft just to keep up. The AT-11 Kansan taught most of America's bombardiers and aerial gunners their trade, close to 1,600 of those. And the Model 18 in all its military forms, the C-45 Expeditor and the AT-7 Navigator among them, more than 4,500 airplanes. The XA-38 was the first combat aircraft the company had ever designed. Bill Cassidy led the project with a small group of specialists under him handling armament, control surfaces, wings, hydraulics, landing gear, and the engine installation. The new XA-38 was an all-metal monoplane with conventional landing gear. It flew on a pair of Wright R-3350 duplex Cyclones, the same engine family that powered the B-29. They had a 2-speed supercharger and water injection, which pushed short-term output from 2,300 to 2,440 horsepower. The water system carried 52 gallons, enough to keep detonation at bay through a takeoff and a full power climb. That word, detonation, followed the R-3350 everywhere it went. It was a difficult engine rushed into service before it was ready. Its rear cylinders ran hot because the cooling baffles sat too close to the cowling. It had a habit of swallowing valves, and its crankcase contained enough magnesium that an engine fire could reach a core temperature around 5,600 degrees Fahrenheit and burn through a wing spar in seconds. On the XA-38, testing showed the engines were prone to detonation in high blower, so high blower was locked out and the aircraft was flown in low blower only. The Army had its own ideas about how close air support ought to work. That is why the XA-38 turned out to be a fairly large twin-engine plane. 67-foot wingspan, just under 52 feet long, about 22,500 pounds empty, and up to about 36,000 fully loaded. Unlike the Il-2 or the Henschel 129, the Grizzly barely carried any armor at all. Beech was betting on speed and firepower instead. Its main gun was a 75mm T9E1 cannon mounted in the nose directly in front of the cockpit. It was not really one gun, it was three pieces: the gun tube itself, a mechanical feed unit designated T13, and the mount that held them. And the complete installation was later standardized in American service as the M10. The barrel was 7 feet long, the shell it fired weighed about 15 pounds, and 20 rounds sat in the nose in a circular magazine. The whole assembly came out around 1,100 pounds once development had finished trimming weight out of it. That is a lot of iron to hang in front of a pilot's feet. What mattered most was that feed mechanism. The 75mm guns the Army already had. Flying were descended, almost unchanged from the M3 gun in the Sherman tank, and in the B-25G and B-25H they were loaded by hand, the navigator wrestling 15-pound shells into the breech in a cramped compartment of a pitching aircraft. In practice, that meant about 4 rounds on a firing pass. The gun recoiled 21 inches along a rail that ran back under the pilot's seat, and even with spring absorbers and reinforced structure, the whole airplane shuddered and seemed to break in midair every time it fired. The British had come at the same problem from another direction. Their Mosquito FB Mark 18, the one they nicknamed the Tsetse, carried a 57mm Moulins gun, an auto-loading version of the 6-pounder anti-tank gun with 25 shells, and kept its rifle-caliber machine guns purely so the pilot could walk his tracer onto the target before firing the big one. It worked within limits. A Tsetse helped sink U-976 off the French coast on March 25, 1944. But the attack profile was punishing. A dive from around 5,000 feet at 30 degrees held steady until the aircraft was inside about 1,800 yards, which is a long time to be a straight and predictable target. Only 18 of them were built. Beech's gun loaded itself. The pilot could put the entire magazine downrange without anyone in the aircraft touching a shell. Underneath it sat a pair of 50 caliber Brownings. The whole nose gun bay swung open on a hinged panel for servicing, and there were 500 rounds for each of those Brownings. The gunner sat in a compartment behind the wing, remotely controlling 2 turrets, one dorsal and one ventral, using a periscope. The turrets were General Electric blister units, and General Electric was the company doing precisely this work for the B-29, whose central fire control system used 5 sighting stations and 5 electronic analog computers to let gunners aim turrets they could neither see along nor reach. Those computers took in airspeed, gravity, temperature, humidity, and the lead the gunner needed, and solved for where the guns had to point so that he only had to keep his sight on the target. On the XA-38, the same principle was boiled down to 1 man and 2 turrets. Each turret housed another pair of 50 caliber M2 machine guns, 500 rounds per gun again, with interrupter mechanisms built into the system so that the gunner could not shoot the tails, the propellers, or the wings off his own aircraft while tracking a target across them. The upper turret could fire straight back between the fins. The lower one could be swung around to point forward, which meant that on a strafing run the pilot had 4 heavy machine guns firing ahead of him instead of 2. In addition, 4 hardpoints under the wings could carry up to 2,000 pounds of bombs or drop tanks. On paper, the same racks could take torpedoes, depth charges, even smoke tanks. Sources disagree on how many men flew it. Most say 2, a pilot up front and a gunner in the back running both turrets. Others count 3, with a weapons operator of his own between them. It was as big as a medium bomber, but dropping bombs was never really the point. Its wingspan was within a foot of a B-25 Mitchell's. Beech thought of it more as a heavy interceptor. With that much firepower and the speed they were predicting, it was supposed to be able to tear into bomber formations and hold its own against fighters. That, in fact, was where the whole design had started. When Beech began work in the spring of 1942, the Model 28 was conceived as a bomber-destroyer, an aircraft meant to break up a formation of heavy bombers with a single shell rather than to hunt tanks in a field. The name the company gave it, Destroyer, was meant quite literally. The mission changed, the name stayed. All that remained was securing enough engines. That one bottleneck killed it. Beech started building the 2 prototypes in 1942, and then the work stalled for 6 months. The issue was a shortage of Wright R-3350s, nearly all of which were earmarked for the top priority B-29 Superfortress program. These were not small numbers. Wright's own plants in New Jersey and Ohio turned out somewhere near 14,000 R-3350s during the war. And Chrysler's Dodge Chicago plant, purpose-built for the job, produced over 18,000 more, working thousands of engineering changes into the design along the way, direct fuel injection among them, to make it something crews could live with. One variant alone, the -23A, ran to more than 22,000 engines. Every one of them was spoken for before it came off the line, and 2 engines for an experimental attack plane in Wichita was not a request anyone in Washington was in a hurry to fill. By the time engines were finally available, the Army Air Forces had largely lost interest in the project. It went the same way as the Lockheed XP-58 Chain Lightning, which was scrapped shortly after completion. The XP-58 first flew on June 6, 1944, managed 25 test flights in total because everything else at Lockheed had higher priority, and by early 1945 had been reduced to a non-flying instructional airframe. Lockheed had ended up paying for most of the first aircraft itself, with the government covering $451,000 of changes it had ordered and putting close to $1.9 million into a second prototype that was never built at all. Even so, the Army went ahead with a full flight evaluation on the completed XA-38. The Wright R-3350-43s were rated at 2,300 horsepower for takeoff. They turned 3-bladed Hamilton Standard propellers 14 feet across, constant speed and fully featherable. It was a mid-wing airplane. The wing used a NACA 23,000 series airfoil, 626 square feet of wing area, with 5 degrees of dihedral. Every rivet on the outside of the aircraft was flush, and the skin joints were butted rather than lapped, which cost money to build and bought back speed. Inside the wing sat 4 fuel tanks holding 640 gallons, with 2 more behind the cockpit holding another 185, all of them self-sealing. Beech put the fuel pumps at the top of the tanks rather than the bottom, so that a tank holed in combat would not simply pump itself dry through the hole, and plumb the system so that either engine could draw from any tank. The single-wheel main landing gear retracted hydraulically into the engine nacelles, while the tail wheel pulled into its own fuselage bay. To give the gunner a clear field of fire to the rear, Beech gave it a twin tail. It flew for the first time on May 5, 1944. Some sources say the 7th. It was piloted by veteran Beech test pilot Vern Karstens. It did not go entirely smoothly. Coming back in to land, the aircraft stalled about 10 feet above the runway. Karstens fed in power, went around, and put it down cleanly on the second approach. He would spend the rest of his career doing exactly this sort of work as Beech's chief test pilot and manager of flight test engineering. It was Karstens who took the Model 35 Bonanza up for the first time on December 22, 1945, and came back reporting it about 10 miles an hour faster than the engineers had calculated. It was Karstens who first flew the Model 34 twin quad in October of 1947, and Karstens again who lifted the Model 45 off the ground in December of 1948, the aircraft the Air Force would buy as the T-34 Mentor. The first flights went up with wooden dummies where the guns would go. By July, after a hard round of company testing, they moved on to live fire with the 75. The gun was first fired on the ground on July 1, 1944, on the gunnery range at Great Bend Army Airfield in Kansas, and then in the air over Kansas later that same month. Most of the cannon work would eventually fall to the second airframe, which was the one completed with its guns and turrets actually installed. In October, the Army sent its own man to look at it. Captain Jack W. Williams flew the aircraft from October 13th through the 24th, 1944. checking the cannon and machine gun installations and the fire extinguishing system. He reported plenty of stall warning, Buffy threw the tail well before the break, and said it landed well and handled well on the ground, and that it was, in his own phrase, very maneuverable for an airplane of its size. It did everything the Army asked of it without complaint. So on August 14, 1945, they sent it to the Proving Ground Command at Eglin Field, Florida. There it flew another 38 hours in the hands of Army pilots working over its weapon systems and the cannon above all. Officially named the destroyer, it became much better known by its unofficial nickname, the Grizzly. The second prototype made its first flight on September 22nd, but by then the Army Air Forces had lost interest in continuing the program. The surrender of Germany, and soon after Japan, ended a long list of programs that never got their chance. The XA-38 landed on that list as well, as close air support went to fighter bombers and light attack aircraft. To make matters worse, the scarce engines were still desperately needed for B-29 Superfortress production, which remained the main priority. And not only for the B-29, by 1945 the Navy had two new single-engine attack airplanes lining up for the same engine, the Douglas BT-2D, which became the Sky Raider, and the Martin Mauler. American thinking about close support was already moving toward exactly that kind of machine. One engine, one man, a heavy load of ordnance, and no defensive turrets at all. The airplane tested better than anyone expected, especially on speed. The story you usually hear is that the Grizzly walked away from a P-51 that tried to intercept it. The real story is better than the lore and slightly different from the way it usually gets told. Beech needed a chase aircraft to calibrate the XA-38's airspeed system and started out with a company Model 18, which could not get anywhere near the speeds involved. So the engineers borrowed a factory fresh P-51B instead. As the calibration runs climbed toward 375 miles an hour, the Mustang could not stay with it. The best figure recorded was 376.5 miles an hour on war emergency power at a takeoff weight of 32,000 pounds. The figures usually quoted are 370 miles an hour at 17,000 feet, a service ceiling of 29,000 feet, 2,600 feet a minute on the climb, and a range of about 1,600 miles. The Army pilots who flew it in the evaluations liked it, and so did the ground crews. It was easy to work on, and it did not break. It was extraordinarily maneuverable, and it could get in and out of short dirt strips that nothing else its size could touch. The specification had called for it to come off the ground at 105 miles an hour. It came off at 91. It came back over the fence at 125 with 45 degrees of flap. And crews looped it, half-rolled it, slow-rolled it, side-slipped and skidded it, all in a 30,000-pound aircraft with a field gun in the nose. Control forces went heavy as the speed came up, but the controls stayed effective. And the guns worked. If the war had gone differently, the Army would have ordered it into production in 1944. If the war had run longer, a production A-38, fast, heavily armed, built like a bridge, would very likely have gone to work over the front line. As it was, the Army already had in hand an aircraft that would do the job. Ed Heinemann had designed the A-26 Invader against a requirement written back in 1940. Douglas flew it in July of 1942, had it in combat over New Guinea by the summer of 1944, and built more than 2,500 of them. It was fast, it carried a heavy bomb load, it did not need an engine the B-29 line was waiting on, and it was already in squadron service. So the Grizzly had no future. One of the two prototypes was scrapped not long after the war ended. Nobody knows what happened to the second one. It was supposed to go to what was then the Air Force Museum. What is known is that in 1948, one of the two aircraft was flown to Davis-Monthan in Arizona and earmarked for the museum at Dayton, Ohio, and that it never arrived there. Beech closed the file for good on June 2, 1955, when the company destroyed all of the engineering and lofting data for the Model 28. The only pieces of the Grizzly that outlived it are its guns. Two of the 75mm guns survive. One at the National Museum of the United States Air Force in Dayton, and one at the Air Force Armament Museum at Eglin on the same field where the Grizzly flew its last 38 hours.